Projected economic growth in aerospace, robotics, and renewable energy sectors by 2035. An overview. Introduction. The economic landscape is set to undergo a significant transformation in the coming years, particularly in the aerospace, robotics, and renewable energy sectors. According to projections by the World Economic Forum (WEF), these sectors are expected to experience a 30% growth by 2035, driven primarily by increased investments in Mars colonization technologies and enhanced international collaboration initiatives. This report delves into the key findings of the WEF, which foresees the global space economy expanding from $630 billion in 2023 to an impressive $1.8 trillion by 2035. Economic projections and drivers. The WEF's recent report outlines several critical factors contributing to this anticipated growth. 1. Expansion of the space economy. The global space economy, currently valued at $630 billion, is projected to triple in size by 2035. This surge is expected to outpace the growth of global GDP. Largely fueled by advancements in space-enabled technologies such as communications, positioning, navigation, and Earth observation services. 2. Sectoral contributions. Over 60% of the growth in the space economy is forecasted to come from adjacent industries, including supply chain and transportation, food and beverage, state-sponsored defense, retail, consumer goods, and digital communications. As these sectors increasingly adopt space technologies, their operational efficiencies and market reach will expand dramatically. 3. Decreasing launch costs. A notable trend in the space sector is the tenfold reduction in launch costs over the past 2 decades. This decrease has facilitated the entry of new players into the market, enabling a broader range of applications and innovations. The emergence of mega-rocket technologies is expected to further enhance access to space, spurring additional growth. 4. Technological innovations. The integration of artificial intelligence (AI) and satellite technologies is anticipated to revolutionize various industries, optimizing processes and improving decision-making capabilities. For instance, AI-driven innovations will enhance resource management in agriculture, insurance, and construction, leading to more sustainable practices. 5. Social and humanitarian impact. Beyond financial returns, the growth in the space economy is poised to address pressing global challenges, including disaster management and climate monitoring. Space technologies are increasingly recognized for their potential to contribute to social and humanitarian efforts, making them essential tools in global development. Timeline of projected developments. 2023, current valuation of the space economy stands at $630 billion. 2024 to 2025, continued investment and innovation in Mars colonization technologies and international collaborations are expected to accelerate technological advancements across sectors. 2030, significant contributions from AI and satellite technologies will manifest, improving operational efficiencies across various industries. 2035, the space economy is projected to reach $1.8 trillion, reshaping industries and contributing to solutions for global challenges. Sector-specific insights. 1. Aerospace sector. As advancements in space technologies proliferate, traditional aerospace companies are likely to face competition from non-traditional players leveraging space technologies for improved logistics and transportation solutions. The aerospace sector will benefit from innovations that enhance satellite communications and navigation systems. 2. Robotics sector. Robotics is set to play a crucial role in space exploration initiatives, particularly in Mars colonization efforts. The development of autonomous systems for construction, resource extraction, and habitat building on Mars will have direct applications on Earth, where robotics can enhance productivity and efficiency in various industries. 3. Renewable energy sector. The intersection of space technology and renewable energy is particularly promising. Satellite data can be utilized for optimizing energy production from renewable sources such as solar and wind, while AI can enhance energy management systems to reduce waste and improve efficiency. Collaborative efforts and international initiatives. The success of these projections heavily relies on international collaboration efforts among governments, private sectors, and research institutions. The following initiatives are vital: public-private partnerships. Collaborative projects between government agencies and private companies will be essential for developing and deploying space technologies. Such partnerships can facilitate funding, resources, and expertise sharing. Global research initiatives. Joint research initiatives focusing on Mars colonization and space technologies will foster innovation and accelerate technological advancements. By pooling resources and knowledge, international teams can tackle complex challenges more effectively. Educational and training programs. As the demand for skilled professionals in aerospace, robotics, and renewable energy grows, educational institutions must adapt their curricula to prepare the workforce for these evolving sectors. Initiatives that promote STEM education and training in space technologies will be critical. Conclusion: the projected 30% economic growth in the aerospace, robotics, and renewable energy sectors by 2035 underscores the transformative potential of space technologies. As investments in Mars colonization and international collaborations increase, these sectors are poised to benefit significantly from advancements that not only drive economic growth but also contribute to addressing global challenges. By embracing the potential of space technologies and fostering collaborative efforts, stakeholders across various industries can unlock unprecedented opportunities that pave the way for a more sustainable and prosperous future. The projected 30% economic growth in aerospace, robotics, and renewable energy sectors by 2035, driven by investments in Mars colonization technologies and international collaboration, reveals several counterintuitive insights. 1. Space economy growth versus traditional industries. While the aerospace sector is traditionally associated with high costs and limited market dynamics, its projected growth highlights a shift where it becomes a foundational component of a broader economic ecosystem. The fact that over 60% of space economy growth is expected to arise from non-traditional sectors like retail, food and beverage, and supply chain management contradicts the notion that the space industry is insular and solely focused on its own advancements. Instead, it suggests that space technologies will fundamentally transform a diverse array of industries, enhancing their efficiency and capabilities. 2. Lower launch costs leading to broader accessibility. The significant reduction in launch costs over the past 2 decades has made space more accessible, contrary to the expectation that only large, well-funded entities would benefit. This democratization of space access allows smaller players and startups to innovate and compete, which can lead to a surge in creativity and technological advancement across various sectors. The idea that space technology could revolutionize everyday services like ride-hailing apps or agricultural monitoring is a noteworthy departure from traditional perceptions of aerospace as a niche market. 3. Investment in space as a social good. The expectation that financial returns from the space economy will be accompanied by substantial social benefits such as improved disaster management and climate monitoring introduces a dual-purpose narrative. The idea that investment in space technology can simultaneously drive economic growth and address pressing global challenges like climate change and inequality challenges the conventional view that economic development often comes at the expense of social and environmental considerations. This reflects a growing recognition that economic strategies can align with humanitarian goals. 4. Interconnectedness of AI and space technologies. The integration of artificial intelligence (AI) with space technologies presents a counterintuitive perspective on technological advancement. While AI is often viewed as an autonomous driver of innovation, its role in enhancing space technologies suggests a more symbiotic relationship. The potential for AI to optimize resource management and improve decision-making in industries reliant on space data illustrates that advancements in one domain can significantly elevate others, leading to holistic growth rather than isolated progress. 5. The role of non-traditional players. The diminishing share of traditional space hardware providers in favor of non-traditional players underlines a shift in the economic landscape. This challenges the assumption that established companies will always dominate emerging markets. Instead, it indicates that innovation may arise from unexpected sectors such as digital communications and consumer goods, which may leverage space technologies in novel ways. This trend reflects a broader economic transformation where agility and adaptability become more valuable than sheer size or legacy. 6. The upside and downside projections. The report indicates a potential upside estimate of $2.3 trillion for the space economy by 2035. Contrasting sharply with a downside projection of $1.4 trillion if there are significant technological stalls. This range underscores the uncertainty inherent in economic forecasts and challenges the traditional view that growth trajectories are linear and predictable. It highlights the importance of fostering a supportive environment for innovation, as stagnation in technological advancement could drastically alter the projected outcomes. 7. Global investment disparities. The call for substantial investments in climate transition, particularly in emerging markets, reveals a counterintuitive disparity. Despite the potential for significant returns from green technologies, many regions remain underfunded. The notion that Africa, despite having abundant solar resources, received minimal investment in clean energy further emphasizes that potential does not always equate to actual investment. This highlights the need for strategic investment frameworks that acknowledge and bridge these gaps rather than perpetuate them. 8. AI's dual role in emissions. While AI is positioned as a key driver in reducing emissions and enhancing efficiency, it simultaneously has the potential to increase energy consumption through data processing demands. This duality complicates the narrative around AI as a purely positive force in climate action and emphasizes the need for intentional deployment strategies to ensure that AI's environmental impact remains beneficial. It suggests that technological solutions often come with complex trade-offs that require careful consideration. These insights collectively challenge conventional wisdom regarding the space economy, technological investment, and the interplay between economic growth and social responsibility. The evolution of the space sector into a pivotal driver for diverse industries and global challenges reshapes our understanding of economic development in the coming decades. The report on the projected 30% economic growth in the aerospace, robotics, and renewable energy sectors by 2035 reveals several critical insights that many may overlook, which could significantly impact our understanding of economic growth and technological advancement in the coming years. 1. Role of non-traditional sectors. One significant detail often overlooked is the decreasing share of traditional space hardware providers in the broader space economy. As the report notes, over 60% of the growth in the space economy is expected to arise from non-traditional sectors like supply chain and transport, food and beverage, retail, and digital communications. This indicates a shift from a focus solely on aerospace and defense towards a more integrated approach, where industries not typically associated with space are leveraging space-enabled technologies. Significance: this represents a paradigm shift in the economy, suggesting that space technologies will become integral to a diverse range of industries. Companies that traditionally do not engage with space technology may need to adapt and innovate, making this a critical area for investment in business strategy. 2. Impact of lower launch costs. The report highlights a dramatic reduction in launch costs, which have fallen tenfold over the past 2 decades. This reduction is a crucial enabler for the projected growth in the space economy, allowing more frequent and cost-effective access to space. The emergence of mega-rocket technologies by the early 2030s will further enhance this accessibility. Significance: lower launch costs can democratize access to space, enabling not only larger corporations but also startups and smaller enterprises to engage in space-related activities. This trend may foster innovation and competition in the space sector, resulting in a more diverse and robust market. Moreover, the ability to deploy satellites more affordably can accelerate advancements in industries such as telecommunications, agriculture, and disaster management. 3. Interconnectedness of sectors. The report emphasizes the interconnectedness of the aerospace, robotics, and renewable energy sectors, particularly through advancements in AI and satellite technologies. For example, the utilization of satellite data in agriculture can optimize resource management and enhance decision-making processes. Significance: this interconnectedness suggests that advancements in one sector can have cascading benefits across others. Policymakers and business leaders must recognize these interdependencies to create holistic strategies for economic development. By fostering collaboration across these sectors, stakeholders can unlock new opportunities for innovation and efficiency. 4. Socioeconomic benefits beyond economic growth. An often overlooked aspect of the report is the emphasis on the social benefits of space technologies, particularly in addressing global challenges like climate change and disaster management. The potential for space technologies to improve disaster response and climate monitoring is highlighted as a dual benefit of economic growth and social good. Significance: this underscores the importance of viewing economic growth initiatives through the lens of social impact. As investments are made in space technologies, it is essential to consider how these advancements can contribute to humanitarian efforts and sustainability. Companies that align their strategies with social good may gain a competitive edge in the market as consumers increasingly favor brands that are socially responsible. 5. Potential for new business models. The report suggests that as space technologies become more accessible, they will enable the emergence of new business models across various industries. For example, ride-hailing apps that rely on satellite navigation services exemplify how traditional businesses can leverage space technology. Significance: the emergence of new business models can lead to a transformation in how industries operate. Companies that can adapt to these changes will be better positioned to capitalize on the benefits of space technologies. This also presents an opportunity for entrepreneurs to innovate and create solutions that address both market needs and societal challenges. 6. AI as a catalyst for growth. The role of artificial intelligence (AI) in driving growth within the renewable energy sector is another significant yet overlooked point. AI's ability to optimize energy systems, enhance climate modeling, and improve agricultural practices indicates that it will be a key player in the transition towards sustainable energy solutions. Significance: recognizing AI's potential in other sectors can help organizations align their strategies with emerging technologies. By integrating AI into their operations, businesses can achieve greater efficiency, reduce costs, and enhance their competitive advantage in a rapidly evolving market. 7. Investment trends and economic resilience. The report states that investments in space technologies reached record highs exceeding $70 billion in 2021 and 2022. This trend is expected to continue with diverse investors entering the space sector. Significance: increased investment indicates a growing recognition of the importance of the space economy as a driver of future growth. Investors looking to diversify their portfolios should consider opportunities in the space sector as it demonstrates resilience and potential for high returns. Additionally, this trend can be a signal for policymakers to create favorable conditions for investment in space technologies. 8. Global collaboration as a driving force. The report highlights enhanced international collaboration initiatives as a driving force behind the anticipated growth in the space economy. Countries are increasingly recognizing the value of working together on space exploration and technology development. Significance: this collaborative spirit can lead to shared knowledge, resources, and innovation, ultimately accelerating advancements in space technologies. For businesses, understanding the dynamics of international partnerships can provide strategic advantages when entering global markets. Conclusion: the projected growth in the aerospace, robotics, and renewable energy sectors by 2035 is not merely a statistic but a reflection of profound changes in technology, business models, and societal needs. By recognizing and understanding the significance of these often overlooked details, stakeholders can better position themselves to harness the opportunities presented by this burgeoning sector, ultimately contributing to both economic prosperity and a more sustainable future. 1. Projected economic growth in the space economy. The anticipated growth of the global space economy, projected to reach $1.8 trillion by 2035, represents a significant shift in economic dynamics. This growth is almost twice the rate of global GDP and is primarily fueled by advancements in space-enabled technologies. As investments in space-related technologies have surged, with over $70 billion invested in 2021 and 2022, the aerospace sector is becoming a crucial player in the global economy. This economic boom is not just about traditional space industries. Over 60% of the growth is expected to come from sectors like supply chain and transport, food and beverage, and digital communications. This highlights a transformative potential where space technologies will increasingly integrate with everyday industries, reshaping how businesses operate and compete. 2. Role of international collaboration. International collaboration initiatives are essential for harnessing the full potential of space technologies. The development of Mars colonization technologies exemplifies how countries are working together to achieve common goals in exploration and technology advancement. By pooling resources, knowledge, and expertise, nations can accelerate the pace of innovation and reduce costs associated with space exploration. Collaborative efforts can also lead to shared benefits such as improved disaster management capabilities, climate monitoring, and humanitarian responses, thereby addressing pressing global challenges. This cooperative framework will be pivotal in ensuring that the economic growth projected in the aerospace, robotics, and renewable energy sectors is sustainable and equitable. 3. Impact on global challenges. The integration of space technologies into various sectors is poised to have profound implications for addressing global challenges, particularly climate change and disaster management. Space-enabled technologies are increasingly recognized for their ability to provide critical data and insights that can enhance efficiency across industries. For instance, advancements in AI-driven innovations in satellite data are expected to improve resource management in agriculture, enhance disaster response capabilities, and monitor environmental changes. This dual role of space technologies as both economic catalysts and solutions to pressing global issues underscores their significance in future planning and policymaking. 4. Transformation of industries through technology. The expected transformation of multiple industries through the adoption of space-enabled technologies cannot be overstated. With launch costs decreasing significantly and new technologies emerging, sectors such as agriculture, insurance, and construction are set to benefit immensely from improved data accessibility and operational efficiency. For example, Earth observation satellites can provide vital data for optimizing agricultural practices, while AI can enhance decision-making processes in disaster management. The convergence of aerospace, robotics, and renewable energy sectors will create innovative applications that not only drive economic growth but also foster sustainability and resilience in the face of environmental challenges. This transformation will position these sectors as integral parts of a future economy that prioritizes technological advancement and ecological stewardship. 1. NASA's Apollo program, 1961 to 1972. The Apollo program was a monumental undertaking by NASA, culminating in the historic Apollo 11 mission that landed humans on the Moon in 1969. This program not only achieved its primary goal of lunar exploration but also resulted in significant technological advancements and economic growth in various sectors, including materials science, telecommunications, and computing. The investment in space exploration during this era stimulated private sector innovations and laid the groundwork for modern aerospace technology. The collaboration among government, private industry, and academia was crucial, showcasing how a focused initiative could lead to widespread economic benefits and technological progress. 2. The Manhattan Project, 1942 to 1946. The Manhattan Project was a research and development project during World War II that produced the first nuclear weapons. It involved a massive collaborative effort between scientists, engineers, and military personnel from the United States, the United Kingdom, and Canada. The project led to unprecedented advancements in physics, engineering, and materials science, and its impact extended far beyond wartime needs. The technologies developed during this project have since influenced numerous fields, including energy production, medical imaging, and materials engineering. The collaboration across disciplines and nations during the Manhattan Project is a historical example of how focused investment in technology can yield significant economic and societal transformation. 3. The European Organization for Nuclear Research (CERN) and the development of the World Wide Web. 1989, CERN, the European Organization for Nuclear Research, is known for its groundbreaking research in particle physics. In the late 1980s, Tim Berners-Lee, a computer scientist at CERN, developed the World Wide Web to meet the growing demand for information sharing among researchers. This innovation revolutionized communication and commerce, leading to the Internet's explosive growth and the emergence of the digital economy. The collaboration among international scientists and researchers at CERN not only advanced our understanding of fundamental physics but also catalyzed the development of technologies that transformed the global economy. The economic impact of the Internet is immense, with estimates suggesting it contributes trillions to the global economy, highlighting the importance of international collaboration and technological advancement. The future outlook for the aerospace, robotics, and renewable energy sectors is highly promising, with a projected economic growth of 30% by 2035. This surge is primarily attributed to increased investments in Mars colonization technologies and international collaboration initiatives, which are anticipated to revolutionize the global economy. Here we explore the key trends, predictions, and implications of this growth trajectory. Economic growth and sectoral expansion. The World Economic Forum (WEF) predicts that the global space economy will expand to $1.8 trillion by 2035, nearly tripling from $630 billion in 2023. This growth rate of approximately 9% annually is significantly higher than the projected global GDP growth. The expansion will be fueled by advancements in space-enabled technologies, including communications, positioning, navigation, and Earth observation services, which are expected to permeate various industries. Notably, over 60% of this growth will come from sectors beyond traditional aerospace, such as supply chain and transportation, food and beverage, defense, retail, consumer goods, and digital communications. This trend indicates a paradigm shift where non-traditional sectors increasingly leverage space technologies to enhance their operations. Investment landscape. Record high investments in space-related technologies exceeding $70 billion in 2021 and 2022 underscore the growing confidence in this sector. The dramatic reduction in launch costs, falling tenfold over the past 2 decades, and the emergence of mega-rocket technologies are expected to facilitate further expansion. By the early 2030s, the accessibility of space technologies will revolutionize industries in ways comparable to the impacts of smartphones and cloud computing on everyday life. Addressing global challenges. The anticipated growth in these sectors is not solely about financial returns. It also holds the potential to address pressing global challenges. Space technologies are increasingly recognized for their role in disaster management, climate monitoring, and enhancing humanitarian responses. For example, AI-driven innovations in satellite data are expected to optimize resource management and improve decision-making processes in agriculture, insurance, and construction. Technological innovations and AI. Artificial intelligence (AI) will play a critical role in driving growth across these sectors. It is positioned to accelerate innovation, optimize operations, and enhance the efficiency of various systems. For instance, AI can improve grid stability and productivity in power systems, forecast supply and demand, and facilitate the integration of renewable energy sources. The World Economic Forum emphasizes that AI has the potential to reduce emissions significantly by enhancing the adoption of low-carbon technologies, thus aligning economic growth with environmental sustainability. Collaborative efforts and policy frameworks. Successful navigation of this future landscape will require intensified collaboration among diverse stakeholders, including governments, private sectors, and civil society. A supportive policy framework will be essential for fostering innovation and ensuring equitable access to the benefits of space technologies. Investments should be directed toward applications that deliver the highest social and environmental returns. Promoting sustainable growth. Timeline of projected developments. 2023, space economy valuation at $630 billion. 2024 to 2025, continued investments and focus on Mars colonization technologies and international collaborations. 2030, significant contributions from AI and satellite technologies across various sectors. 2035, projected growth of the space economy to $1.8 trillion, reshaping industries and addressing global challenges. Conclusion. The future of the aerospace, robotics, and renewable energy sectors is poised for unprecedented growth driven by investments in space technologies and international collaboration. This expansion will not only reshape the global economy but also provide innovative solutions to some of the world's most pressing challenges. By embracing the potential of space-enabled technologies and fostering collaboration among stakeholders, society can unlock significant economic and environmental benefits, paving the way for a sustainable and prosperous future.